Question 2 says, a student investigated the efficiency of an electric motor using the apparatus shown. This is the apparatus. The motor was connected in a circuit including a battery and a switch. The student connected additional components to determine the power of the motor. Complete the circuit diagram for the circuit the student should use. Okay, so what are we trying to find out here? We're trying to determine power, right? So if you recall the equation, by the way, this is not some mechanical power we're dealing with. We're dealing with the power of a motor. A motor is an electrical device, and you have to find out the electrical power, right? So the equation for electrical power is VI, right? So the circuit that you have to draw has to include an ammeter and a voltmeter because these are the two quantities that you need to find out to determine the power. So the question clearly said there was a battery. So this is the symbol for a battery, a collection of cells, and you need an ammeter here, has to be in series, and a switch as well, right? So there has to be a switch, and you have to place a voltmeter in parallel with the motor. There you go. This is your circuit diagram. Part B says the student closed the switch in the circuit and the motor lifted the mass from the floor. She used a meter rule to measure the height gained by 1 kg of the mass in 10 seconds. Describe how she should measure a single value of the height. So you have to find out the height, measure the height as accurately. The other keyword in the question is accurately. You should include the use of any additional apparatus, right? So if you go back in the diagram and see what height they're asking you to find out. So this is your diagram, and you have to find out the height that this mass rises, right? So this height is obviously a vertical distance. So you have to ensure that your meter rule is vertical as well. And what do we do to ensure your meter rule is vertical? You use a set square. Then you have to keep the meter rule very close to the mass. Otherwise, you'll have a very large parallax error. And speaking of parallax error, you have to take readings perpendicular to the scale to avoid this parallax error. And so that the ruler stays in a fixed position, you have to clamp it as well. So these are your 4 marking points. I'm writing down the points for you to see. So again, these are your 4 marking points. To ensure that the meter rule doesn't move around while taking measurements, you have to clamp the meter rule in a fixed position. The height is a vertical distance, so you have to ensure that your meter rule is vertical, and you do that using a set square. And place the meter rule close to the mass. Also take measurements perpendicular to the scale to avoid parallax error. So the next part of the question says, explain why repeat measurements are appropriate for this measurement. So there will always be some random error that will cause variations in the values. So repeat readings allow a mean value to be calculated to give a more accurate value. Part C says, explain how the measurements made by the student should be used to determine the efficiency of the motor as it lifts the mass. We were just solving this question in my class the other day. So I asked my students that what do we use to calculate efficiency? And they said output by input. I said absolutely fine. Output what and input what? Then I asked output power or output energy, input power or input energy. Answer is actually either one works. You can calculate efficiency using both power or energy. Please bear this in mind. This is very useful. So for this specific question, I'll refer to the energy bit because that's more relatable to me. All right, so let's look at the diagram. So what's going on here is You are supplying the motor with some electrical energy, right? So in other words, for this entire system, this electrical energy can be thought of as the energy input, and electrical energy, the equation you know from your IGCSEs, right? The equation is VIT, right? And the output is raising this mass. And when you raise this mass, what energy does this gain? It gains gravitational potential energy. We call that E graph. And the equation for E graph is mgh, right? So you can think of this as your output energy. So you have output, you have input, and you know the equation for efficiency is output by input. So literally, this is how you can format your answer. So energy output equals mgh, energy input, which is in the form of electrical energy, is VIT. So efficiency is useful output by total input, that is mgh by VIT. That's it. This is your 3-mark answer.